Determine the equation of a line that has a slope of 2 units and the perpendicular distance of square root of 5 units from the origin. Okay, let us begin. So here, let's try to understand the problem graphically first. So here we have the xy coordinate system. We have a straight line L. Let's say it has the x-intercept at the point A and the y-intercept at the point B. And also we have a point D on the line L such that this is the OD is going to be the perpendicular distance of the line L from the origin. Now here OD is denoted by P. And let's suppose that OD, this perpendicular length, makes an angle of alpha with the positive direction of x-axis. That in that case, the equation of the line L is given in the normal form as x times cosine of the angle alpha plus y times sine of the angle alpha, and that is going to be equals to the perpendicular length OD. This is the equation of the line. Now what we have to do here is we need to determine the equation of the line, and for this line the slope of the line is given. So it has a slope of positive 2, although according to the diagram it cannot have a slope of positive 2 because this is the angle that the line makes with the positive direction of x-axis. So if we consider it to be theta, then tangent of theta comes out to be negative. So actually this is not the correct figure for the equation of the line, but this is going to help us solve the problem. So it's fine even if we start with a incorrect representation of the line. At the end we're going to get the correct representation. This is purely for understanding. Okay, so here it's given here that P that's equals to square root of 5 units, and this line has a slope of 2 units. So what we'll do, we're going to suppose the equation of the line. So let the equation of the line be, so we're not going to use this equation of the line, although this is the normal form of the line. We'll come back to this in a moment. We're going to use the slope-intercept form of a line to represent the line L. So let's say let y equals to mx plus c. Let this be the equation of the line. This is going to be the equation of the line L, where m is the slope of the line, L is the slope that the line makes with the positive x-axis, and C is going to be the y-intercept. So now what we are going to do is we're going to take the equation that we assumed, the slope-intercept form of a line, and we're going to write it in the general form. The general form is given by ax plus by plus c equals to 0. So that is the general equation of the line. So let's convert it into the general equation. So we're going to get negative, we're going to get m times x minus y plus c equals to 0. So if we write in this fashion, then we have a that is going to correspond to m, then we have b, so that is going to be equals to -1, and the c value that is going to be equals to the lowercase c. Although the slope is given to us, so a value comes out to be equals to +2. Now what we'll do next is we're going to find out the square root of a squared plus b squared. So that's going to give us the value square root of 5. This will become evident in a moment why we're using this value, because if we have the general form of a line ax plus by plus c equals to 0, then the normal form of the line is given by -a divided by square root of a squared plus b squared times x. Then we have -b divided by the square root of a squared plus b squared times y, and we have -c divided by the square root of a squared plus b squared. So that's going to be equals to 0. This is the normal form of the line. So that is why we found out the value of square root of a squared plus b squared, which means that our equation can now be expressed as -a. So what is -a here? -a means we have m value is +2. So we have -2 whole divided by square root of 5 times x. Then we have -b. So we need negative or b that corresponds to -1 divided by square root of 5 times y. Then we have -c. So c corresponds to the value c in lowercase divided by square root of 5. So this is going to be equals to 0. Okay, so let's further simplify. Now we have -2 over square root of 5 times x added to y over square root of 5. Then we're going to transpose the third term to the right hand side to get c times c divided by square root of 5. If we compare this particular equation with the normal form of the line, so here we get cosine of angle alpha. So this is going to be where alpha is the angle that the perpendicular line we have OD in our case makes with the positive x-axis. So according to this formula, so sine of alpha, that becomes equals to -2 over square root of 5. Then sine of the angle alpha, so this becomes equals to 1 over square root of 5. And then the perpendicular distance P, so that comes out to be equals to C over square root of 5. However, it's already given in the problem, the perpendicular distance P, that's equals to square root of 5. It's already provided in the problem, the square root of 5 unit, but P equals to square root of 5, which implies in place of P, we have C over square root of 5 equals to square root of 5. So solving for C, we're going to get 5 units. So here we have successfully obtained the value of C. Now we can substitute this C back into our original equation. So we get, so now we have y equals to 2 times x plus 5, or simply put, we have 2x minus y plus 5 equals to 0. This is the required equation. It's going to be the required equation of the straight line.